So qualitative chemical analysis. Qualitative has to do with the quality of something. So here what we're looking at is what kinds of ions are present in a solution. Not how much, not the concentration, but which ions are present. This is different than quantitative analysis, which is looking at how much of it there is, the concentration. So you can do qualitative analysis by selective precipitation, and this is often called wet chemistry. It's largely been replaced by less time-intensive instrumental techniques. But if you watch some of those detective shows that are set back of like the 1800s and stuff, Murdoch Mysteries and Father Brown, those kinds of things, you'll see them with their test tubes, right? And they're taking this sample and they're adding something to it and see if the color changes, right? What they're doing is a qualitative analysis, because they know, well, if I add this particular reagent and there's any cyanide present in there, the solution is going to turn red. And if there's no cyanide, it won't. And so that'll tell me that this person died of cyanide poisoning or whatever.
This is like the test they use to test to see if there's certain drugs inside of a certain compound that's found. There are tests that are still used to just identify the presence of a particular compound, and that is qualitative analysis. Yeah. Some of it is not technically wet chemistry anymore because you've got this like dry probe or something, right? And I guess technically the COVID swab tests, not the ones that they do in the lab, but the ones you can do at home, that's technically a qualitative analysis test. Is this thing present? Yes or no? So here's an illustration, and you might want to pay attention to this topic because your lab practical is a qualitative analysis experiment where you'll be given solution with 2 ions in it, and you'll have to figure out what they are. We will practice, so we'll be doing a whole bunch of reactions with known ions so that you see what they look like. And this is where you can feel like, an old-fashioned detective or something. So these are sometimes called qual schemes, qualitative analysis schemes. The main idea here is I've got this test tube with 3 cations in it. And so I'm going to add something that will precipitate one of them. In this case, it's going to precipitate cation B. So essentially all of cation A is now a solid at the bottom of the test tube. So I can decant, I can pour this liquid off, and often what we'll do is we'll use a centrifuge to really ram all of that precipitate into the bottom so that we can decant more easily. You don't have to worry about precipitate floating up. So we decant that. Now we have a test tube with just cations B and C. We'll add another precipitating agent. This one is going to precipitate out cation B. Again, centrifuge the tube, decant the liquid. So now I've got cation A in this tube, cation B in this tube, and cation C. Yeah, this is cation A, doesn't it? Oh, I'm writing in the wrong place. It's cation C. So that's the idea. So there are several different qual schemes. This is not the one that we're going to use in lab, but the idea is similar. And you'll need to draw a flow chart like this to follow when you do your lab practical. So up here, these are all the possible cations that could be in this particular sample. So if we add 6 molar hydrochloric acid, that's going to precipitate this group of ions, silver, mercury 1, and lead 2, because these compounds are insoluble with chloride. The other ions, other than the purple, are still going to be in the container. Then we could add hydrogen sulfide and 0.2 molar HCl, and that would precipitate out this group of cations. These are called the acid-insoluble sulfides. So for these cations, the sulfides are not very soluble in an acidic solution. Then we still have yellow, green, and blue left. Now we're going to add hydroxide and bring the pH up to 8, make it basic. Now we're going to have base-insoluble sulfides precipitate out and insoluble hydroxides. So aluminum, iron, chromium hydroxides. So now we've just got the green and the blue group left. We can add ammonium, hydrogen phosphate, and ammonia to this, and we can precipitate out barium, calcium, and magnesium, because these form insoluble phosphates. And then what we've got left are the alkali metals and ammonium. Sodium, potassium, ammonium. There's nothing that precipitates them. So how do we identify those guys? Well, we'll get to it. So this is the long version. Most chlorides are soluble. So if you remember from the rules, these are the exceptions, right? We take that acidic mixture, make it basic. Treat it with hydrogen sulfide. And then we get the sulfides that are insoluble in acids. So the concentration of sulfide here, because this is actually an acid dissolved in water, right? Hydrosulfuric acid. The concentration of sulfide will be pH dependent. Because this is a diprotic acid, it loses 1 hydrogen, giving us a hydrogen sulfide ion, and then that loses another hydrogen to give us a sulfide. So we can kind of adjust the concentration of sulfide by changing the pH. So these guys will precipitate with a low concentration of sulfide. Then at base, the base is going to shift the equilibrium for the hydrosulfuric acid and increase the sulfide ion concentration. So now we get these guys. Their sulfides are more soluble than the previous group, but they're still relatively insoluble. And we'll also get the insoluble hydroxides precipitating out. And then we can remove the alkaline earth metals, magnesium, calcium, barium, by adding ammonium phosphate. So what do we do with those last 3? Well, we could do a flame test. Sodium gives a very intense orange-yellow flame. Potassium gives kind of a lavender flame that's sometimes hard to see. But you could distinguish which, do you have sodium, do you have lithium, and if you know that there's something in there, and you don't get a color with the flame test, then you know it must have been ammonium. Any questions? So this is separating out groups of ions, right? The qual scheme that we're going to do for the lab practical has recipes for separating out and identifying specific ions, but the idea is the same.